This video is sponsored by PCB Way, where you can print all your PCB ideas, make them a reality.
All right, the 18650 battery cell is the best battery on the planet. It has been in production the longest. It is the most abundant. It's been used in everything for about 35 years now, right? It's in rockets for NASA. You know, remember the spacesuit that NASA had where the astronaut was flying around in this little chair or whatever? 18650s power that. You know that little helicopter that it's in Mars right now flying around, powered by 18650s? These batteries are everywhere. They are the best thing that has happened in modern times. It's a modern marvel of engineering right here, right? But what about its newer, bigger brother, the 21700? A lot of you guys have asked me, when am I gonna make my little PCB project for this new version of the batteries, right? If you don't know what I'm talking about, I have made this PCB version of a battery module, right? And this is super popular. I think I've lost track of how many of these have been produced, but somewhere around 100,000 of these things have been produced. Half of those have been produced by me on my own website. We sell them on jack35.com, right? But the other half is DIY. It's an open source project, so you can download it. You can print the things yourself. You can buy these from many sellers in many other platforms in China, including AliExpress and all the other big platforms, right? So this is super popular. People have been asking me, when am I gonna update the design to be able to accommodate the 21700s? And I said, hey, you know what? The 21700s are too new. They're a thing. They're too expensive. They're a thing that are hard to get. The day that I have a pallet or a couple pallets of these batteries in my warehouse, then I'll make into the. Guess what? I've now for a little while, for the better part of a year, I think I've had pallets of these batteries on our website, brand new, and I haven't made the thing yet. So I gotta do good on my promise of designing a PCB board for these so that you can quickly and easily make battery modules using these cells without having to, well, know too much about batteries and not having to have specialized equipment to spot weld or other stuff, right? So today I'm gonna run you through the process of making design software, right? And so I'm just gonna do a time lapse because it takes quite a while to do this. A few hours, probably like 4 hours or something like that. It's taking me. I'm not the quickest one. I am a novice at making PCB boards. This is my first one that I ever did. Since then, I've made, I don't know, a dozen others. Maybe, I don't know, at this point, like 20, 25 or something. So, but I'm still not very proficient at making this stuff. You're right, I'm self-taught. So I probably am doing things not the way that the other people do them and stuff. So I am just gonna speed right through this thing, and then I'm gonna do a voiceover and explain why you might want to do and why I'm doing the things the way I'm doing them, and you know, that sort of stuff. So let's start this video by showing you the PCB making process. Okay, so the first thing you will have to figure out how to do is the mechanical, right? So this is the dimensional size of everything, right? And so what I'm doing here is just drawing up the holders. These are the little plastic battery holders that I bought on AliExpress that hold the cells, right? Those are the ones that are going to go and are going to populate this PCB, right? And for the purpose of holding the cells, right? So I measure them, I use a caliper, and then, you know, measuring, and then I'll draw the footprint here. So a lot of the times, this sort of stuff, this is considered a component. And so a lot of times you could just go into this program, into a library of known components, and you can sometimes find them there, right? But on this time, I just didn't bother even looking for that. I know, like connectors, stuff like that, usually you're able to find it. But stuff that it's a little bit weird or new, it's hard to find it, so you might just be better off just starting and doing it like this. And there is a way to make that into a component, right? The footprint, and then you submit it up to this library so that others in the future that are designing a PCB board, then they can use all this work that you're doing. So you can choose to. In this case, I didn't do it. I just went and started drawing it on the actual, well, this is a PCB drawing, right? This is a board drawing, not a component one. And so that's what I'm doing here. See those green layers are basically, I'm just using those as guidelines, right? So I'm measuring, and then I'm thinking like, okay, so from here to the edge of the little holder to where the first pin, it's X amount, 11.68 or, 11 and a half or something like that, right? So then I'll just make that in there, and then I'll put it. It just helps me guide. It's just, gives me a visual aid. This is just what I do. I don't know if that's the right way to do it. Like I said, like I'm self-taught doing this, so I don't know. There's maybe other ways of doing this. Now, a thing that I kept coming up against here is that I kept seeing that the dimensions were not adding up, and as it turns out, the caliper that I have at home might not be very accurate, and so I had to. That's why things weren't adding up, and it wasn't until the second part of this drawing that I, compared it with the caliper that I had in the office. I took the one from the office at home, and then I was trying to do it, and I'm like, oh, okay, that's the problem. The problem is that these dimensions that I'm getting from the thing might not be very accurate, and so therefore, that's why I kept it just didn't add up visually when I was doing this, right? But, here I'm measuring the second, from the first pin to the second pin, and then I put the little hole in there, and then I'm going across, and I'm trying to use, guidelines so that it's not crooked, and, it's like all the dimensions have the same, the same numbers, right? So it adds up. So the purple outline there, that is the actual PCB outline, right? That's the board outline. And then these yellow ones those are called silk screen. And so it's basically just a paint layer, right? That the PCBs have. And you have the yellow one is the top silk screen layer, and the bottom, and the green one is the bottom one. So here what I did is I realized that I have done this many times before, and so I'm like, why am I starting from scratch? I can just go and copy and paste from the other boards that I've already done, right? And so that's gonna eliminate a lot of work, right? Why reinvent the wheel when I already did it? I already dropped most of this. This board is going to be very similar to the other 4S that I did for the 26650s. It's just the dimensions are going to be different because there's a different, so the board, the cells dimensions are different. But everything else is the same. I'm using that same connector. I'm using the XT90 connector, or that's an XT60 connector. And so there we go. Now I'm just adjusting the dimensions there on the outer board, right, by just moving those things in there, and then there we go. Okay, so that's what it looks like. This is the 3D rendering, and it kind of gives you an idea. So then I go into some of my other designs there, as you can see, and I'm trying to bring some of those in here to, just to copy other stuff. Like you see those pads are bigger on that 4S board, right? And I have already gone through the whole process of, going back and forth to see what the best size is for that, right? And so sometimes when we're the only way to test this stuff, right, is to actually draw the board and then get it in your hands and then try to populate it. And then you start thinking about things like, I should have a bigger solder pad in here so that the solder flows better, or I need more distance between this connector and that connector because it's really hard to populate, to put the connector in there once it's in. And a lot of these things, you can't see them until you have the physical board right in front of you. And so that's why I'm going and using a lot of this stuff from the other boards that I've designed before, because I already went through that process of like double checking and moving things around so that everything works and everything works better, right? And so now when you're designing a thing, you might not have that, right? And you might have to just start from scratch, and it's just going to be kind of trial and error. What you have to do is, draw up your first iteration and then order it and then get a sample, get it in, and then play with it and do the thing. And then you're like, yeah, this is a stupid mistake. How come I didn't see it, right? Like, okay, so let's change it. And then you change it, you revise it, and then you order. And that's why you have to order these sample batches of these boards, because it's gonna take a few tries for you to try, especially if you have no experience or like me, right? A lot of these markings will help you once you're populating these boards, once you're using these boards. The more information you have there, then the less you have to think about, right? And then not just on the front side, sometimes you're like, I wish I would have put these markings on the bottom side because, well, the top side gets covered by the components, right? And so you can't see those marks once it's populated. You flip it around, and it's like, the mark's on the wrong side. So then you wanna get some of these marks also on the bottom so that you can see them. Okay, see, now here what I'm doing after I got the dimensions, the mechanical dimensions of the board, right? And all the placement of the connectors and the whole thing. The next thing to do is to now start running the pads. These are the copper layers. These are the layers that are going to transfer the power, the electrical energy from one, pad to the other, right? Or the one component to another, right? And so I guess this is going to be 7 cells in series, and so it just makes sense. And I want all the cells to be oriented in the same way, right? All the positives to one side of the board, all the negatives to the other side, because that makes it easier when you're populating the board. You don't have to flip back and forth, and so it eliminates the chance of people making a mistake. All the positives go one way, and if you're populating 100 of these boards, with cells, then you just get into a rhythm. You're like, okay, just place all the cells facing the same way, you place all the boards facing the same way, and then you populate them without much thinking about it, right? And so it just kind of eliminates the chances of errors, and so that's why I'm doing it this way. Now I'm doing the pad here. This is that layer, right? But you can't connect it. That pad in specific is just to hold that connector in there, so it doesn't. It has to not be electrified, right? I guess you can if you're running some kind of shieldy thing, but you definitely don't want electricity on that thing, because it's basically just to hold the board, the connector onto the board, right? And so that's why I'm going around and cutting around there so it's not touching the actual copper pad or the copper layer, so it's not electrified. Also, another thing that I'm doing here is I'm moving things around, because what you want to do is have the biggest traces of copper, because these are gonna carry up to 5 amps, right? Once we build this board, maybe we'll bump up a little bit, but it all really depends on the weakest component in this board, and that is going to be the cell holder contacts, spring contacts, right? So on the 18650 ones, anything above 5 amps starts heating up too much and starts melting those holders. So that's why we put a 5 amp fuse in the board there, so that the fuse will blow before you start melting your holders, your cell holders, right? And so we're gonna leave that here for now, and then once we do run some tests on these holders for the 700s, we'll see if they're the same. If they're the same, we'll just leave it like that. If they can handle a bit more current, then we'll change that in the board there, and then we'll put the different, that's just the marking in there, right? But the actual sizes of the 5 amp or a 6 amp fuse is the same, so it would be the end of the world if it's like that. So what I'm doing here is now changing, it's like it's gonna go from positive to negative. So all these connections have to be diagonally, right? And that's because all the cells are facing the same direction. So now the terminal on the far left has to connect to the far right on the next one. And so that's what we're doing these here. And of course here I made a couple mistakes that I ended up fixing on later iteration of this. In order to not have to make every single one of these, what you do is you make the first one and then you just copy it and paste it to the bottom. But that means you have to take in consideration certain dimensions so that the top line matches the bottom line, right? And so you don't have to adjust every single one of that. And so I'm playing around with that in here. I kind of did that backwards because I started with the upper sections of that. See, now I'm changing it, and that's, you learn to do things quicker as you go. It's not super counterintuitive. You have to just kind of have to get experience. See here how it doesn't match. Now I have to adjust it, but I adjust that, and then I'm like, that doesn't work, right? It's better if just the same shape works all the way down, and then just do it. I kind of got it right there, but not 100%. And there is the one side, the upper side. Now, there was one day, and then I came back. I think that was like on a Friday, and then over the weekend, my computer froze or something, so I had to restart it. When I didn't realize that I hadn't saved this file, and so I had to start all over, and I had to redo it. And so therefore, the final version might have slight differences that when you're actually seeing in the screen here, but I basically just had to redraw it, right? And I didn't record myself drawing it the second time because I already had all this here and stuff, right? But it's the same concept, and this is what I'm doing. I'm just changing those pads because they're too small, and I figured that out by experience on the first time that I did one of these boards, and I realized that by putting a bigger one, it just helps you a lot by when you're starting to populate the things, right? So then what we're doing now is we're changing down to the back side, right? And this is the bottom layer, copper layer. And so because I'm going to connect that lower pad all the way to the upper pad, right? And it's only going to be on the one side of this board that's going to carry that. Then I want to make that pad kind of large. But I also don't want to connect to those pads in there because those are all the positives and negatives of the cell. So it has to be isolated from that. And so that's why I'm drawing those little lines. And those little circles that I put in there, it just makes it simple to make it nice and neat. And then you can just go back and just cut out like a rough, like what I'm doing here. It's just little tricks that you learn to do so that it doesn't look, like a 5-year-old did it, I don't know, this might be way too much work for a little board. You could just do it like more basic or more everything doesn't have to be perfect and, it's exactly aligned and, but, the better you do this, the better it's going to look and maybe the better it's going to work, right? That's my whole philosophy there. So now what I'm doing is I'm putting a second, right? The back layer, I'm doubling it up on that one there because that is the only pathway where that connector is going to be powered from. And so it's kind of, there's not a lot of surface area there to carry that. So I thought, well, you got to do it on the opposite side. And then it doesn't connect all the way through, but at the very least, if it's connected to the other side, it's going to help dissipate some heat if you ever use that connector there and stuff. So, and then that's what I'm doing here. I'm just basically just doubling up and following the same shape as the top layer on the bottom. And then what we're going to do is we're going to use some bias things on the later to connect the top and the bottom so it could serve as a secondary, just to double up on the copper thickness at the very least on that section of that board. This is the whole philosophy that we're, just put as much copper to use, right? This whole layer of copper is going to be on the board already, right? And whatever you don't end up using, it has to be with an acid, has to be stripped away. It has to be, whatever, I don't know, what is it, melted? Not melted, it's got to be eaten away with acid. So the more copper you end up using, then the less copper that has to be removed from the board. And why not? I mean, copper is good. It's a conductive material that we use here too. And so the more you have on there, the better it will be. So there you go. It seems, okay, now I just got to add that little thing back in there because why not? Again, the more copper you have, the better. And here's where now I'm starting to add the biases. The bias is just it's just a little hole with solder, right? And so it connects the one layer from one side of the board to the other. So the top to the rear, right? And then basically that ties the two layers together. And it helps dissipate some heat and it helps connect the two layers together to double up that current carrying capacity on those layers, right? And so that's what I'm doing here. As anywhere where I can see that it would be beneficial to connect the top layer to the bottom layer, then I put some of those in there. And so that's what I'm doing here. Now this might add a little bit of expense to the board because it is another, basically like every time you add one of those, there needs to be little drill, a tiny drill with a tiny drill bit. These things are super tiny. That has to go into that board and drill one of those, and then when they put solder, then it connects in there. But I think it's useful to do this because then it makes your board much capable of carrying the current that you're going to ask of it. And so this is the part here where I'm connecting the bottom layer to the top layer, right? And the top layer is the one that connects to the board, to the terminal, to the battery terminal, but then the bottom layer is the one that's going to actually carry that current all the way to the top of the board, into the connector, to go into your load. And so those biases, basically those are the only things that are going to connect that thing. And so that's why I added so many of them over here on the bottom, because that's it, right? That's what's connecting that layer. Everything goes through there. Now I'm just kind of carrying around all the, all the markings that are going to help you when you're populating these and when you're troubleshooting. It's like, did I put this board backwards? Well, I don't know. What does it say? It says top, or does it say bottom? Oh, if it says bottom, oh man, I just, this are sort of the things that we've learned throughout the history of doing these that will make the assembly process a lot easier. All right, so that's it. After we finish that design, then all that is left to do is just to export it out as a Gerber file, and then I'm going to upload it to PCBWay. This is a shop in China that makes some of the best PCBs, and we've been using them for a while, and they are sponsoring this video, right? So if you want to get this PCB, all you have to do is click on the link below, go to their website, and then you can just purchase the PCBs there, and you can print as many as you want. Now, keep in mind that this is a preliminary, just the first try at this, so the dimensions might be off a little bit, and I will update it once I get it and I try and I make sure that all the things are done correctly and we didn't make no mistakes and stuff. Then I'll update the file up on their website and stuff, and so now from then you'll be able to. So you're watching this like later, a month, 2 months, 3 months, a year down the line from where this video is uploaded. Then the file is gonna be checked out, and it won't have any mistakes, right? Because we'll work out all those mistakes. But if you're watching this today, the same week or the same day that I'm uploading this, and you want to order, just keep in mind that you might get a few little things here and there. I don't think there's going to be anything critical. It's just going to be a slight dimensions or something like that, right? So, all right. Thank you for watching this video. We'll see you guys on the next one. Bye.